All right, this is the Algebra 1 new Unit 6 Lesson 3 video. So we are continuing this exploration of linear equations, and in particular we're looking at what we call systems of linear equations. So just to give you just a kind of a brief overview of what we're talking about here. A system of linear equations is basically two linear functions that we're looking at, and really what we're asking is, where do they cross each other? Where do they have the same xy point? And so that is what we are looking for. And so there are different methods of getting that. I'll tell you up front, graphing is one of those methods. But we are going to look at the other methods, and to varying degrees, we're going to learn how to do them. But know that graphing the systems, graphing the functions, and finding their intersection point is always one way of finding the solution. So let's jump back to this and let's talk through what the first method is. So the first method that we're going to use to solve these is called substitution. Substitution is a method that basically says you need to isolate one variable first. Could be x or y. So in this equation, I've already got an example where step 1 is already completed. In the first equation of number 1 here, the y is already isolated. The second step is to substitute into other equation. So in other words, whatever we solve for, we're going to substitute into the other equation. So at this, what that looks like is I'm going to take x plus 3, and I'm going to put it in for the y in the other equation. So what that ends up looking like in the next step is I'm going to rewrite equation number 2 to say the following: x plus, and then inside parentheses, x plus 3 equals 5. So I've taken x plus 3 and I put it where the y was in the original equation. So after that, it's just a matter of solving. Solve for other variable. So I'm going to solve and find the actual answer for what does x equal. So to do that, I'm going to go ahead and add this up. We can drop these parentheses. So that's going to make this say x plus 3 equals 5. X plus x is 2x. A lot of this should be familiar to you. We're just doing some basic algebra to solve this. Then we have an algebraic equation that we can solve. I'm going to take 3 away from both sides. That cancels out, leaving me with 2x equals 5 minus 3 is 2. Then I'm going to take and divide 2 on both sides because I want to get rid of this 2, and I get x equals 1. And so that's already the first part of my answer. If my answer is going to be a set of ordered pairs, the first part of that ordered pair is 1, x. Remember, we're talking about this where we have the xy point where these systems intersect. So once I get the 1, then we get to the final step of the process. The final step is to plug value back into the equation, original equation. I would recommend doing it to the one that you started with. In other words, the one that was already isolated. So what I mean by that is I'm going to take 1 and I'm going to plug it in all the way back up here into the y equals x plus 3 equation. So the way that's going to look is I'm going to take this and I'm going to plug it into y equals x plus, what was it, x plus 3. So I'm going to take that, and when I do that, it's going to look like this: y equals 1 plus 3. And so y equals 4. And there's the other half of my answer. And so this would be the solution to this equation. these two cross at the point 1, 4. So here on the sidebar, you'll kind of have your kind of method for doing substitution. And I will post that this will be posted on the lecture notes, so you'll have that. But let's keep going and do some more examples. So that's basically it for substitution. I'm actually going to jump down to number 3 in my examples. Do this one first. I kind of put them out of order. So in this one, again, the first step is we want to solve for a variable, but look, we already have that here. Y has already been isolated in the second equation. So really, I can take what I see here, and I can put it into the y in the other equation. I can put that there. So we're going to do that. So I'm going to take this first equation. I'm going to do 3x minus 2 and then parentheses minus 2x plus 7 equals negative 7. Okay, so this one's a little bit more complicated. There's a lot more going on in this one, but that's okay. We're just going to use all the algebra we know to solve this. We're going to deal with this parentheses first. So we're going to have 3x, and then this needs to be distributed to both of these. So this is going to be negative 2 times negative 2. So that's going to be plus 4x, because the negative 2 and the negative 2 multiply to make positive 4, and then there's an x. And then we do negative 2 times 7. That makes minus 14, because negative 2 times 7 is negative 14. Equals negative 7. We continue to solve. We can combine like terms right here. That gives me 7x equals, and if I add 14 to both sides, that cancels out, giving me negative 7 plus 14 is positive 7. And then my last step is going to be to divide both sides of the equation by 7, giving me x equals 1. And that's the first part of my solution. So I'll just put 1 there. It's going to be, the x value is going to be 1. Now I'm going to take that 1 and I'm going to plug it back in to the original equation. And we're going to use the one that we started with, y equals negative 2x plus 7. Y equals negative 2x plus 7. And we're going to plug in negative 2. We're going to plug in a 1. And we're going to work it out. So I get negative 2 plus 7. Y equals 5. And that's the other part of my solution right there. So in both of those examples, you had the y already isolated. So that just gives you an example of those. I'm actually going to skip down. I do these in a different order than I wrote them down. And we're going to look at number 5 here. So with number 5, they're both already in an isolated form. So they both say y equals. When this happens, it's not really anything different. It just looks different than the other ones. So in other words, I can take this x minus 1 and I can put it in for that y. So I'll end up with this. X minus 1 equals 2x plus 2. All I've done so far is plugged in x minus 1 for y, and then I have to solve this equation. So this looks different, and really that's just because we have to move all the x's to one side and the numbers to the other side. So to do that, I'm going to subtract 2x from both sides. And that gives me x minus 2x. Well, first of all, that cancels out. This is an imaginary 1. X, 1 minus 2 is negative 1x. Minus 1 equals 2. I'm just working this out. 1x minus 2x makes negative 1x. Then I'm going to go and add 1 to both sides. Cancels that out. Negative 1x. 2 plus 1 is 3. Let me go on to our next step. We divide by negative 1 on both sides. That cancels, leaving me with x equals 3 divided by negative 1, which gives me a negative 3. Again, once I get my first solution, let's go ahead and write that up here. We have negative 3 as our x value. And so we go up and we plug that in to either one of the original equations. Go do the first one, y equals x minus 1. And if I plug in, I get negative 3 minus 1. Again, I'm plugging in the negative 3 into that equation. Y equals negative 3 minus 1 is negative 4. And so that's the other part of my solution. So my xy solution for that is -3, -4. So in all these examples, the y was already by itself, or the x was already by itself. So we just went ahead and moved on to step 2. So what if we don't have an isolated variable to begin with? Well, that's what we're going to see in number 2. In number 2, 2x plus 3y equals 12, x plus y equals 5. Well, we need to get one of these to be isolated. So I think the easiest place to start is going to be the second equation. They already have no coefficients. So I'll just subtract y from both sides. That's going to cancel, and it's going to give me x equals 5 minus y. So that might look a little strange at first, but this is now isolated. So we've isolated x, and I can take that and I can put it into the other equation. So 2 parentheses, and since I'm replacing this with x, it's going to be 5 minus y plus 3y equals 12. So everything else about that equation stayed the same, except I replaced x with 5 minus y. So we're going to distribute this 2, and we're going to get 10 minus 2y plus 3y equals 12. We can do some moving around. I can subtract 10 from both sides. Let's go ahead and move that up here. That cancels out, leaving me with, we can just combine these. Negative 2y plus 3y makes 1y. And that makes it very easy because it's already going to be solved. We're combining those to make y. 12 minus 10 is 2. And so there we are. So we already have our first, but wait a second, that's not the x value. That is the y value. So we already have our first part of our answer. It's the y value is 2. So now we're going to take that value and go back to the original equation. And we can actually use the one that we rearranged. X equals 5 minus y. And we can say, okay, if x equals 5 minus y, then x equals 5 minus 2. So then x equals 3. So again, just to talk through the flow of the problem, you isolate one of the variables, x or y, unless it's already isolated. You take that and you substitute that equation for the variable. In this case, I substituted 5 minus y for the x. Solve that equation for the variable. We solved it until we got down to y equals 2. Then take the value that you found and plug it back into the one of the original equations to find out what the other variable equals, like we did here. All right, I'm going to do one more example, and then hopefully you can try these out on your own. Okay, in this one, it looks like the first equation is going to be the one that's easier to solve. So we're going to do x plus 2y equals 7, and we're going to subtract 2. We're going to subtract 2y. X equals 7 minus 2y. And then I'm going to take that and I'm going to plug this into the x value here. So I get 3 parentheses 7 minus 2y minus 2y equals negative 11. So we'll go ahead and work that out. 3 times 7 is 21. 3 times negative 2 is minus 6y minus 2y equals negative 11. We can do some combining like terms here. We see that we have negative 6y, negative 2y. That makes negative 8y. So we have 21 and negative 11 still there. We need to get that 21 across. So we'll subtract 21 from both sides. That's going to cancel. And it's going to give me negative 8y equals negative 32. It's a lot more work in this one. A little bit more involved. That's okay. Negative 8 divided by negative 8 on both sides. That cancels. Gives me y equals 4. Hop back up here, so I'll put my answer here. So y equals 4. And then we need to take that and put it back into this equation right here. So we're going to take that and we're going to put it in. We're going to put it into x equals 7 minus 2 times 4. X equals 7 minus 8. So x equals negative 1. And there's our answer right there. All right. So I've given you examples kind of all the different types of problems you're going to see here. These are all just different ones. Just to kind of talk you through. Number 1 is already set up for you. You have a y equals equation you can use. Number 2, either one of these equations will work in terms of solving. I would recommend the first one, solve for y. Number 3, I would recommend either one, but probably easier is going to be solving the second one for x. X minus y equals 4, solving that for x. 4 is already set up for you. 5 is already set up for you. 6 is already set up for you. All right, so hopefully this video was helpful. Let me know if you want to see more examples or if you want to see maybe one of the problems from the lesson worked out. There is also a worksheet that goes with this. I don't expect you to put every single part of this problem in order like it asks you, but I do want to see you trying to work on these. As we move through this unit, we will start to focus more and more on doing the graphing, and we'll talk about that when we get to it. But right now, we need to have a foundation of doing substitution and the other methods. All right, that's it for this video lesson.